Okay, so let's continue by integrating FreeRTOS into the project. So first, let's go to the project name and right-click and go to New, Source Folder, and let's call the folder Middleware. All right, and now let's create a new folder within the Middleware folder and call it ThirdParty. And this will be just a regular folder, and it's ThirdParty. And this third-party folder could be used for other middleware from any other third party, and in this case, we're using FreeRTOS. So let's create another folder within here and call it FreeRTOS. So go to New, and it's FreeRTOS, and finish. Okay, so next we're going to add the FreeRTOS kernel to the project. So let's go to the software folder in our project directory. And we have it here in our software folder. So let's go ahead and extract it here. And this may take a minute, so I'll fast forward the video for you. All right, now we need to go to the kernel directory. So let's go inside the folder. And let's go into FreeRTOS. And we're going to copy the source code from the FreeRTOS kernel simply by dragging this source folder over to the FreeRTOS third-party folder. So go ahead and select the source folder. Then choose Copy Files and Folders. Then click OK. So this is the entirety of the FreeRTOS source code. And we can trim this down a bit so that we only retain the files and folders necessary for our application. So let's start with the portable directory, where there are various subdirectories for different compilers and architectures. For our purposes, we'll be using GCC, and we'll keep the memory management directory because it contains the heap implementations. So let's go ahead and select down to cmakelist.txt from the top, and we're going to retain GCC as our compiler and the memory management folder, and we're keeping the README as well. So let's right-click on this selection and go to Delete. Next, we'll navigate to the GCC directory under Portable. This directory contains subdirectories for different ARM Cortex processor ports. Since we are working with the ARM Cortex-M4 processor, we'll only need the ARM CM4 folder. We'll go ahead and delete all of the other subdirectories as they're not required for our current application. So select starting from the first folder all the way down to the last. And then we want to deselect the ARM Cortex-M4 folder right here. Then right-click on the selection, go to Delete, then click OK. And just to give you some additional insight, inside ARM CM4F, port.c and portmacro.h make up the Cortex-M port layer. This is where FreeRTOS hooks into SysTick for the RTOS tick, uses PendSV for context switches, and uses SVC to start the scheduler. Alright, so next let's go to the memory management folder. And here we're going to delete the unnecessary heap management schemes. And you've probably heard of various memory management schemes, but we'll go with heap 4. And I'll explain why in a moment when we take a look at the README. Alright, so go ahead and select all. Then deselect heap 4. Then right-click and delete. Okay, so let's open up this README, and it'll take us to the URL. And here we are in the FreeRTOS developer docs under heap memory management. So let's scroll down and go to heap 4. Basically, heap 4 is one of the more commonly used memory management schemes in FreeRTOS, particularly because it combines the efficiency of the first fit algorithm with the ability to coalesce adjacent free memory blocks into a single larger block, which helps to avoid memory fragmentation over time. So that's all I wanted to mention, but feel free to read up on this if you'd like to know more. Alright, so let's go back to the IDE. And next, let's go to the bottom of the source folder and delete these files, as we won't use them in our setup. Okay, now all the files that we need are here. So next, let's add the required paths for FreeRTOS. So let's go to the project properties. Then go to C++ build. And then we want to go to settings, GCC compiler, include paths. And now let's add a new workspace path. And first navigate to the include folder under FreeRTOS, source, and include. And click OK. Next, we need to add the path for the ARM Cortex-M4. So let's go again to the plus button. And this one is under portable, then GCC. And that's our ARM CM4F path, which includes the portmacro.h file. So select that. All right, so be sure that your include paths look like this. Next, we need to add the FreeRTOS config.h file, and we'll grab one from an example project from the STM32Cube firmware package. All right, so let's navigate back to the software directory. And let's step inside the STM32Cube firmware package. Then go to Middlewares, ThirdParty, FreeRTOS, Source, Include. And here we have a FreeRTOS config template file, which we can use to adapt to our needs. So let's go ahead and drag this over to the project config folder. And just copy it into the folder. Okay, and the path to the config folder is already set up. So let's just adjust and correct the name to FreeRTOS config.h. And we can do that by right-clicking on the file and select Rename. And then adjust like so. Okay, so in the next lesson, we'll take a look at this configuration file, and I'll explain some of the important details about the various options. We'll make a few adjustments, and I'll explain how the system core clock variable is updated. And again, the configuration file path is already set up via the path to the config folder, so we can go ahead and include FreeRTOS config.h in main.c, as we may need it included here in future lessons when we implement the runtime stats functions, for example. Okay, now we'll go ahead and Control B to build all. And everything looks good. So let's continue in the next lesson where we'll take a brief look at the configuration file and make a few adjustments. See you there.